Hello, in this video I want to briefly think about the R formulas and as we have here in front of us we have our R sine theta plus or minus alpha and R cos theta plus or minus alpha. And I'm not going to demonstrate a proof of these formula in this video. I just want to think about them more generally, and perhaps in a future video I will demonstrate a fuller treatment, a proof of these formula. But in general, it turns out it's the case that they're very handy. In that if one is given an expression a sine theta plus b cos theta, well, this expression we can express that this either as r cos theta plus or minus alpha or r sine theta plus or minus alpha, and more generally still, it turns out that it's quite difficult to solve problems of this form. I should set that equal to some constant, let's say k. It's difficult to solve an equation to solve for theta in this form, but if we can convert, in this case the left hand side, to one of the R formulas, so say R sine theta plus alpha, then it's much more simple to solve for theta, because what we would get is something, thinking very generally here, as theta arc sine, it would be k over r minus alpha, right? Yeah. So these are very, very handy formulas, but let's think about them. Let's think about them in a way that doesn't so much prove them, but sort of deepens intuition about why they work. And so what we want to start off with, I suppose, is well, let's just rewrite this, because we want to express a sine theta plus minus b cos theta. We want to express this in the form r, let's say r sine, I'll pick sine for this video, r sine plus or minus alpha, where a, b, r, and alpha are positive constants. And so in I suppose expressing the left hand side as the right hand side, let's take the positive case, the plus case. We could take the negative case if we wanted to. It's a bit of an arbitrary selection. The positive case makes life a little bit easier, I suppose, but so what we want to do is set up an identity. So let's just rewrite this a little bit. We get a sine theta plus b cos theta. We're setting up an identity where this is the same as or equivalent to r sine theta plus alpha. And from here, I suppose the central premise, the main points or points of realization when thinking about the R formulas is that not so much, well, they're derived in a way, I suppose, but there's a very deep connection between the R formulas and our compound angle identities, or angle and sum, or angle sum and difference identities. For example, we know if we have something like sine a plus b, that this is, we can expand this out, right, to sine a cos b plus cos a sine b, right? We know that we can expand this out. Well, we can do the same with the R formulas. That's really the main point. And so you don't even need to necessarily memorize these as such, because it's quite simple to, if one is required to ever need to remember how to expand them, it's literally just think of the angle sum and difference identities. And so for the right hand side, we get r, and I don't usually write it this way, but I will for the sake of this video. We get r sine theta cos alpha plus cos theta sine alpha. And now we can just use the distributive property, like so, and so what one ends up getting is r sine theta cos alpha plus r cos theta sine alpha. And so what's really interesting, if we just we still have on the left hand side here a sine theta plus b cos theta. Now what's really interesting is that if we look at these two expressions, we've got set to be equal to each other, to one another, notice the coefficient of the sine term, notice the coefficient of the cos theta term on the left hand side. Notice them in relation to what we have here. If I highlight the next one in blue, we have r sine alpha. If these are set to be equal to one another, which they are, and we've just expanded it out, and we can see if we're setting them to be identical. What's really curious, and actually we can prove this more deeply by looking at the graph transformations, but nevertheless, is that if a sine theta equals r sine theta cos alpha, well, a has to equal, then in this case, r cos alpha. Likewise, if b cos theta equals r cos theta sine alpha, well, b is going to have to equal r sine alpha. And so from there we can set up a system of equations, right? We've got, we can label this equation 1, equation 2, and if we divide equation 2 by equation 1, what do we get? Well, we get b equals r sine alpha over a, which equals r cos alpha. And now we can solve for alpha, and what we end up with is b over a equals tan alpha, right? And that therefore, if we needed to solve for alpha, that's just going to be arctan, or arctan b over a, which is a very helpful result. Going back to what I mentioned at the outset of this video, but deeper still, we can sort of expand on this a little bit more, and and I'm not going to prove this here, but it's always the case that you can solve for r, that r equals r squared principal root of a squared plus b squared. It's always the case that this is true. In other words, r always equals a squared plus b squared, as you can see right here. Although we're not always going to have a and b. You can think of it a little bit more generally if you would like. This is how I remember it. It's that r equals equation 1 squared plus equation 2 squared. It's the same thing, okay? And so then we get, what do we get when we solve for r? Well, we get r equals equation 1 squared. That's going to be a squared. We've got here b, so b squared, which equals r squared cos squared alpha plus r squared sine squared alpha. And we can just simplify some of this. We still have a squared plus b squared on the left. We've got a common factor. We can factor out the r squared. That leaves us with cos squared alpha plus sine squared alpha, and of course it's just a basic Pythagorean identity, which is just equal to 1, so we get r squared equals a squared plus b squared, or in other words, you could take the square root of both sides and you would get your value for r. And so thinking about it more generally is quite helpful in review, in that if one isn't always sure how to convert an R formula, say in this case R sine theta plus alpha, or it could be R cos theta minus alpha, or whatever, all one needs to do is just expand. You're always going to expand on the side of the R formula, and notice really that sine alpha and cos alpha are just constants, and that the variable is theta. And in that sense, and in addition to that, you can treat the expansion of the R formula just as you would treat the expansion of an angle sum and difference identity. So maybe in the following video I'll work on a quick example just to contextualize, I suppose.